Harold D'Souza is a knowledge specialist in all the aspects as far as cable industry is concerned, from testing and quality control to electrical cable design, engineering, and commercial management. His career span over 28 years has extensive knowledge in the construction utilities, renewables like solar, nuclear, wind energy, oil, gas, and petroleum sector. Harold has built his career from working for prestigious brands including Ducap, which is based in UAE, then originally BICC UK, and Telefonica in senior management positions. Harold joined the Basek team with the wealth of experience from cable industries. Based in India, he is focused on supporting cable compliances by driving increased level of standardization. So with this short introduction, I would like to hand over the platform to Harold.
So now we start with our main topic. Today we will explore some insights in the medium voltage cable demand and understanding the challenges. When people talk about the power industry, their focus is usually on the power generation side of the business, or on the utilities, including the extraction of fossil fuel, what is required for the generation of the electricity, and alternate energy such as generation such as solar energy, and carbon emission, all this which Amol has stated in the beginning, and the nuclear power, which is quite important as well, as a green power or a green energy. However, a big part of the industry is a transmission and distribution, where cable plays the main role. It also involves important group of industries that include, production machinery, cable production machinery, manufacturers, high voltage electric lines, as well as the management systems, such as smart grid technology that improves the efficiency of the power. Cable sector is core of the power industry, and if something was to go wrong, it can have a huge impact on business, and more importantly, safety risk in electrical or mechanical or thermal factors of the cable can contribute to a big failure of cable. Problems in these areas can be increased to extraordinary level if the cable has not been manufactured to the right national or international standards to perform continuously to its technical or its merits of the application. Damages can also occur due to the important handling of installation is also plays a very important factor, um, and and the terminations used in the medium voltage cable, unlike low voltage cable, medium voltage cables are having high voltage accessories joints that also have an impact on the whole circuit. Even if the cable is very quality cable, if the terminations or joints are not proper, it can, it can be one of the reason for major failure. And medium voltage failure, if it happens, it can back out to part of the city or a region as well. So they are so important. So this is how it looks as a Indian region, the forecast from 2014 to 2024. The medium voltage industry is gradually uh, improving or progressing well. In terms of the value, the production, it is increasing very consistently, and India is leading its way to success, and there is a huge potential for next 20 to 40 years to grow. With the government building huge power infrastructure and green energy initiatives and policies, central government with the state utilities, uh, uh, working to build a huge infrastructure in the electrical sector. We are building new cities like 100 smart cities. We already progressing well. There are upgradation of cities, and basically where in the city area where there the underground cables are used to, to give a good look of the for the city and the safety, rather than using the overhead conductors. And country's leadership also, as you know, that for many years we are talking about made in India. That is also another opportunity that foreign investment will come on the cable sector as well, and people will be able to produce quality cables, and with the approval, third party approval, they will be able to export. So there are two markets which the cable manufacturers normally of this region are target. One is major is a local market, and there is a export market. The local market, as I said, it is because of the solar energy and electrification of remote areas, what Amal has already said, and upgradation of existing cities, and the smart grid infrastructure is leading the way for demand of surge of MV cables. There are some challenges overhead lines preferred still, because most areas or hill areas or remote areas or rural areas, it is still overhead lines are used. It is also due to the cost of the underground MV cables and the laying cost as well. It is not in the hill areas and all that. If you have to lay the cable, there is this huge amount of cost involved. So cable and the installation cost goes up. So, and also Indian region is quite popular for the aluminum conductors, because they are prepared, because they are economical, and its availability in this country makes them as a choice first. But equally, the conductor is also used in when it comes to extra high voltage cables, and also all the exports regions, where Europe and UK, they all prefer copper cables, and they are exported. The Indian manufacturer export copper cables to the outside country. And export, the advantage of export also, that increases revenues of the manufacturers to receive premium from export market for approved products, because they also invest in the approval. It gives them exposure to the foreign exchange currency and some benefits out of the fluctuation. And as in the slide, it says that when you manufacture a copper cable in the same factory, it gives you 3 times of the revenue, because process and everything remains same. But the revenue that you produce because of the value of the copper, it is 3 times. So it is always optimization of capacity for the local market and the export market that gives manufacturers to make some good revenue or profit, as local market is very competitive. Aluminum and copper are the as you see, the main two metals for electricity conductors. Aluminum is cheaper, as I said, having higher maintenance cost, whereas copper is costlier for the initial investment, have lower maintenance cost in the long run. So breakdown of the copper cables are lesser compared to aluminum. Aluminum tends to expand in when it is overloaded, or the temperature rises, and those lose connections, and makes the aluminum a little bit vulnerable. Otherwise, aluminum is a best conductor of electricity. So MV cable standards are very important to confirm capability and compliance of cables to work in any local area or a variable climatic condition. Advanced cabling system and the proper installation is also, as I said, is very important. Accessories, as I said, and installation is also very important. And integrating to smart technology is become so important to control the losses, to control the circuits, and avoid the breakdowns. The right design and the stringent testing standards required for efficient and safe transmission of power. The important elements in power and transmission are overhead lines, as you know, power cables, electrical conductors, insulators, and power transformers. So implementation of uniform and strict standardization is so important to select the right cables for different applications. This also supports utilities to roll out energy efficient technologies, from efficiency of transformers to energy efficient conductors. Other areas that pave the way in developments for the digitalization of the or the automation of the electrical grid. The technological advancement in the medium voltage cable is a very important thing. Topic, the slide you are able to see. The changes made to cable design based on the technological advance that impacts the likelihood of electrical or mechanical thermal failures semi cables. Technological advancement means, what I mean to say here is that people tends to change the raw materials to reduce the cost, and that really impacts unless the change the design or the process should be carefully considered and type tested again when the material is changed. If you change any material, your existing type test is becomes invalid. So that is one of the reason this slide is that is a very important decision that someone has to make. If you change the material, you need to have a new type test to confirm that that material newly used or developed or meeting the requirements in a operation condition by doing a stringent test through type test. Yeah, importance of quality is another issue. The poor quality can lead to cable products are sourced to use in power network. They should have a quality. There are several risks involved which can impact safety and performance if quality products or approved products are not taken into consideration. Cables that have not gained third-party approval cannot evidence that they meet the industry requirements and have been thoroughly tested, determine they are safe and fit for purpose. The characteristics of the cable increase the risk of failure, which can result in costly downtime to make the repairs or potentially replace the whole cable entirely. And company's reputation can also be damaged if quality, as I said in the beginning, the blackout of the region, a city, can cause because of the poor quality cables. So now we will move to medium voltage cable design to show you what the cable design looks like. Testing difference between type testing and a product license or a product approval of various MV design cable or testing standards. In this sector, in this section, we firstly look into type testing and determine a comparison between the medium voltage type test and the product approval. This is how the two cable looks like. You can see left side is a medium voltage cable construction with the circular copper conductor, whereas the low voltage cable can be a sector with the sector shaped conductor. The medium voltage designs are more complex than their low voltage counterpart, as they are used in critical application and are relied upon safety for transportation of energy. Both the processing and the structure is totally different to LV cable to ensure that the required end user applications and performance requirements are met. Construction conductor are circular, as I said. The sharp edges are not allowed in a sector shape. You tend to receive that sharp edge, and medium voltage cable, due to the high stress or high voltage, they need to have a uniform surface. That is one of the reasons that they are circular. And medium voltage cable, you can see there are three layers as the insulation, which is a triple extrusion. The layer of the insulation is quite thick. Over the conductor, there is a semiconducting screen is put to reduce the stress on the surface of the conductor, and for the insulation from the inner part of the insulation. Plus, there is over the insulation, there is a conductor insulation screen. So, conductor screen, insulation screen, and the main insulation are done in one process in a CCV line, continuous catenary vulcanization, we call it CCV full form. Whereas the low voltage looks very simple design, until the laying up stage or until the bedding. Before the bedding, they two are different, but after the bedding, normally they could be same. So now we are going to talk about what is a type test. Type testing provides a snapshot of the quality of the cable at a certain point in time. It also known as one-off testing and checks that cable sample meets the requirements of the relevant standard to provide a specifier or end user with the knowledge that the sample supplied is compliant to a particular standard. It is useful if a batch of cable is being supplied for a particular project. However, it is important to note that the raw material or any change in manufacturing process could impact on a cable performance, which would mean the type of test performed would not be relevant in the future. So that is the reason there is no consistent testing to check, unlike product approval. Type testing is a testing. We say it is testing on the golden sample. Manufacturer specifically make a one good sample for the type testing. But when it comes to product approval, it is totally a different, which I'm going to cover you in the next slides, which specifically I have made them. With the increased use of alternative materials, also is an easy way to, for a cable manufacturer to differentiate their product ranges. Adapting to the material, cheaper material to build up cable. I mean, to reduce the cable cost. So that is the reason, type test it should be repeated if it is once it is done, and also it doesn't give a guarantee through consistently if it is not tested in between by a third party. And as a result, it also calls for independent type testing before the product reaches this thing. In the medium voltage cable, normally the concept and requirement is that the type test by a third party is very important. And the BASIC as a approval body believe any changes made to the cable design or even a process, it has to be retested or retype tested. So these are the comparison between the standards in the medium voltage cable. These are the standards. IEC 60502 Part 2 is quite popular standard used worldwide as a generic standard. Any part of the world, this is quite acceptable. In India, as you know, IS 7098 is -2 is for medium voltage cable. That the pole you understood that medium voltage cable means. It is in India 3.3 kV to 33 kV. It is one standard. When it comes to British standard, the voltage grade is for 3 kV it goes under the low voltage standard itself. But 6.6 kV to 33 kV is the medium voltage standard. In British standard, there are two standards separately. 6622 is for the PVC bedding and sheath cable, whereas 7835 is a low smoke zero halogen sheath cables, which is normally used within the buildings for the safety and quality safety issues, where it is very important or specified. 7870 is an armored cable, single core or three core. When it comes to 6622, 7835, there is no unarmored cable. They are all armored cables. And British standard covers a separate standard 7870 for medium voltage unarmored cables. So British standard is quite organized. They don't mix everything in one standard because it is often a confusion when it comes to IEC standard. People make anything and everything, which is a design not experimented, not tried, because customer asks for something and some design for certain application, they are free to do that. But whether the design is really worked, it is tested or it is in the commercial use, nobody knows. So there is some risk of that standard, but otherwise it gives a very good flexibility. Whereas when it comes to British standard, it is clearly given from conductor to dimension to thicknesses, everything is and test very, very, very clear. So 7870 is normally used in again by UK utilities for by generation utilities and the distribution utilities. 7870-4.10 is for single core cables, copper or aluminum, and 7870-4.20 is three core cables. When it comes to 4.10, there are three voltage grades are covered, and they are all single core. When it comes to 4.20, they are three core cables and only one voltage grade, that is 11 kV or 12 kV. Otherwise, as you can see from the design, they are unarmored cables. They can be with the MDP sheath. There is no PVC here. You can see that because utilities where they are used to use in the underground or underground stations, I mean metro station or railway stations, they probably use MDP sheath because of its ability to observe. I mean, not observing the water when they are placed in the water exposed areas. So MDP is so important because it is water resistant, some kind of. Low smoke zero halogen is important when it is installed within the building. So when it comes to testing of the medium voltage cable, there are three types of testing: type test, sample test, and routine test. So the type tests are a requirement of enable to, as I said, explain approval to be assessed to by a manufacturer, including all components, whole cable components, electrical test, mechanical test, all the tests to be done on individual compounds. When it comes to sample test, it is basically undertaken on a representative number of cable samples, which will be agreed as a part of the contractual quality plan with the contractor or a purchaser or utilities. We call it also FAT, which is a factory accepted test, where certain kilometers or certain types of cables are produced and offered for inspection. Then the third party inspection body or the end user selects a random sample from the quantity offered. The routine tests are conducted on every length of cable, on a completed cable in the manufacturing process, or during the process itself, each stage of the cable industry, uh, cable manufacturing process, where from conductor to insulation, sheathing, bedding armor, on the process also it is tested. So I will cover more on that in the next slide. This is how they look like. What is the difference between three types of the test? Um, in a type test, if you can see, there are a lot of electrical test, which is partial discharge test, tan delta, heat cycling, impulse test, voltage test, adherence to short circuit test, and resistivity of semiconducting screen. Similarly, mechanical test on the batting or separation sheath, material insulation, and compatibility of the cable. When the cable is, whole cable is put into the oven for certain days, 14 days or 7 days, as per the standard says. The material reaction between the components should not affect any quality of insulation or sheath in its mechanical properties. Hence, it is tested. Corrosive gas and acid gas for the low smoke zero halogen sheath cables and armors as well tested. Fire and smoke when it comes to PVC or low smoke zero halogen cable. So sample tests are basically, the contractor or third party witnesses on conductor examination, and some insulation hot set test, which is applicable for insulation of XLP insulation, strippability of small and dimensional checks. So routine test, if you can see in the medium voltage, high voltage and the partial discharge has to be done as a routine test. Very important. Partial discharge test in the medium voltage cable should be done on every completed length, every dispatch length. I wouldn't say every completed length should be tested for partial discharge. So partial discharge to ensure that the insulation is strong enough to withstand the high voltages for a long life. There is no leakages and all those stuff. So the difference between the type test and the product approval, which I said that I will cover later. In case of type test, one sample is tested, and when it comes to product approval, we tested minimum 8, which is 16 for the new customer, but a customer who is consistently performing good quality throughout our audits, it is 8 per year. A number of sizes tested in the type test is they normally choose either a biggest one or a middle sample from the biggest size or smallest size. Between that, a middle size they perform or a largest size they test. But when it comes to product approval, all of the sizes, randomly taken. It is not only minimum and maximum. And there is no auditing to check if there is any material changes done during the, after 1 or 2 years by the manufacturers. So we do, when it comes to product approval, there are 3 audits done per year to see the process is same, the materials are same, nothing has changed. In fact, there is no validity period, which is now coming in by some utilities in the Middle East or the Europe, and they are insisting every 5 years it has to be, even if the material is same, it has to be re-type tested. But when it comes to product approval, continuously we do the testing, routine testing. We pick samples from the market and all those stuff. It could be we or anybody, any third party. They have their own system to follow. But what I mean to say is that the product approval is giving the reassurance or consistency of the quality, but the one-time product type test wouldn't give. So next, I'm just trying to cover the value of approved product. In medium voltage cable, these are three are very important. Big utilities ask for this test. When I was in Middle East, all the utilities like Diva, Advia were asking for the tree retardancy test on the completed cable. Normally, tree retardancy test is on a XLP compound, before the manufacturing, and it has to be tested to ensure that the enhancements of properties of cross-linked polyethylene, uh, that they can offer superior reliability and longer performance in high stress cable designs. It has to be done at the component level, as I said, but some utilities can ask to do it on the completed cable as well. A series of in-depth tests are undertaken as a part of the retardancy test. That is a big subject. To prove these characteristics are, the cable compounds used are, or the even, not only cable compounds, the processing is also so important in a CCV line, curing of the three layers. There is a simultaneous process, and also to confirm enhanced electrical performance, projected long life, high water tree retardants. I mean, there can be cracks because of the high moisture or some water moisture. Insulation can become weak. The cracks can develop. That is what called the formation of tree inside the insulation can weaken the insulation. That impacts the performance of the cable, and it can improve heat resistance as well if the compound is tested here for the retardants, and enhancing processing. The retardants XLP also gives good performance for the manufacturing. It is enhancing the performance of the CCV line. So water protected is another thing which is quite popular again in the Europe, UK, and it should be in part of many areas in India, and it is quite popular in the Middle East because being a desert, the water is just half feet or 1 feet, or there is water. When the medium voltage is laid, they need to be protected from water. So there is water block conductors are used, or water block designs are used, that they can block the water coming into the conductor or spreading through the cable length. So that is very important. And the third one is, the external conductor layer or conducting layer on the outer sheath to check the integrity of the outer sheath, during the commissioning, because any pinhole or a small damage on the cable sheath can, water can come into the cable and it can destroy the cable within no time. So it is very important to check the integrity of the sheath. It is consistently okay. So the voltage is applied between the conducting layer and the armor to say that there is no pinholes or any damage of the sheath. So the value of the approved cable, I just made this slide to show why the approved cable is more quality, having more quality or taken care for the quality. There are several reasons that demonstrate that the value of approved cable is listed on this slide. Independent approval demonstrates, verification that cable has been designed and contains the suitable materials to perform for the intended use, and it is done in an independent lab. Third-party cable involves rigorous testing of sample and outside the manufacturer's area to improve the credibility of the manufacturer to claims and manufacturer's claims of the cable quality. Ongoing surveillance is a key part of the process, to enable the BASEC or any approved body has a dedicated team comes and checks that. Cable industry expert auditors are visiting the site and seeing it. Also, cables are taken from the marketplace. Approved cable is, very important for your power generation and distribution, and to confirm the specification complied with. So before I conclude, I would just like to urge end users, project consultants, or any specifiers to use the approved cable and safeguard your power and utility projects by using approved cables.